Don't forget your mic.
So you're being properly recorded. If you forget everything I say in the next 20 minutes, remember this. That's the website that I maintain. You go to this website and you click on the link, Physics for Future Presidents. And you will get my textbook, which is online. You will get my current class, get some idea what's going on. Before I start, I just have to mention two things that Alex decided not to mention about Astronomy 10. One was, oh, you want my, do I really need this microphone? Oh, yes, I do. No, okay, I'll get it on tape, microphone. Okay, two things that Alex neglected to mention when talking about what he, when he was making his presentation. One was that, I don't know, 5 or 6 years ago, Daily Cal had a vote among all the students on campus, and he was elected the best teacher on campus. Yeah. So you should know that. Second little thing he neglected to mention was he was talking about these discoveries in Berkeley, like the accelerating universe done by these people on Berkeley. He was one of the key people involved in that discovery. So, you know, he's a little bit too shy. The only time I'll ever call Alex shy, but okay, I have a very specific agenda today. I was really delighted I'm invited because I want all of you to take my course next semester. It's Physics 10, and I really want you to take it. If you don't take it next semester, I'll be teaching it the semester after that too. But I believe everybody should take physics. And the reason people don't take physics is the fault of the physics department. So I'm in the process of changing that. Typically, the course Physics 10 has been called Physics for Poets. And in fact, I don't know how many of you aspire to be poets, but that's nice. Physics has a nice poetry to it. But I think physics is really important. I think it's the thing everybody needs to know. I think most of you probably really want to know this stuff. And those of you who will choose not to take physics probably choose not to take it, not because you're not interested, but because you're a little bit afraid of it. In particular, there's the mathematics angle that scares off a lot of students. They're afraid of the math. My approach to physics, Physics for Poets, has typically been, well, you know, your math ability is limited, therefore let's tell you about the beauty of physics. Okay, and that's not my approach at all. My approach is, look, you guys are not really interested in math. It's not one of your talents. It's not the thing you feel real comfortable about. So let's skip over it. And let's get to the really interesting and most important, the really important things, the things you need to know. I am dead serious. Are any of my students here? Yeah, okay, a few. The students who are here know that I am dead serious when I say I am teaching this class with the expectation that every one of you will someday be important. You may be president of the US or president of a company. You may be a CEO or chief justice of the Supreme Court. You may be a defense lawyer. You may be an environmental lawyer. You may be a businessman. What physics do you need to know? Well, there is physics you need to know. Even if you're only going to be a voter, there is physics you need to know. I'm going to go over a list of some of the topics that we have covered this semester and some that we'll cover in the future. And my goal is, after every lecture, when you leave that lecture, your feeling is, you know, I really need to know that. It should be absolutely blatantly obvious that this is important stuff for you to know. Not only that, but you'll discover, and this is a problem I have with getting GSIs for this course, most physics majors don't learn this stuff because they're learning the foundation. They are so involved in learning the math so that later in their lives they can teach themselves the important stuff, but they never get to the important stuff. And what do I mean by important stuff? Well, okay. Let me just say that I've been teaching this course now for 3 years. Never once has any student dropped my course because I had too much math in it. And yet, and this is inspired largely by Alex's course, his course is tough, his course is hard, his course is one where you really learn a lot, and that's what I'm doing in Physics 10. This is not an easy course, but I don't have you doing abstract calculations, solving 3 variables and 3 unknowns. Instead, I have you doing a lot of writing about technology. See, physics is the liberal arts of technology. It is the foundation from which you can learn about a new technology when it comes about. And that's why I think everybody should take it. I mean, I say I want all of you to take it. I want everybody at Cal to take it. I want everybody in the United States to take a course like this. So I'm trying to create a new course, a course that if what I imagine is I take the current president or the past president or past presidents, and I say, suppose I have one semester to teach them. What am I going to teach them? Am I going to teach them about the beauty of physics? I want to teach them the physics you need to know. So let me give you a couple of topics here. By the way, my exams, 50% of them are essay questions. The rest are multiple choice. And I'll give you examples of what I mean by the essay questions. Okay. There is some math in the course, but it's optional for those students who want to take more math. It's there for them to learn. I just don't put it on the exams. So, topics. Well, how many of you know, for example, the relative energy content of chocolate chip cookies compared to dynamite? Turns out chocolate chip cookies have 10 times the energy. I teach that the first day in class. Dynamite is good not because it has lots of energy, but because it releases it quickly. This comes up over and over and over again in the class. We learn about hybrid engines. I've been teaching about hybrid engines for 10 years. What are they? What do they do? Why are they so important? Why are we all going to be driving them in 10 years? Solar energy. We'll come back to a nice example of that in a moment. Did you know that if you have a square meter of solar cell and you want to drive your automobile, and you get an efficiency that is 3 times better than anybody has ever achieved, you will have a 1 horsepower automobile? Nice. Okay. Hydrogen economy. What is that? Bush talked about it in the State of the Union message. He introduced it. Everybody here should know what the hydrogen economy could mean, what it doesn't mean, what people think it means that it doesn't mean, and so on. Satellites. What kind of satellite would you launch if you wanted to launch a weather satellite? What about a spy satellite? Can you really see license plates all around the world? This thing, you know, there's so much misinformation on this. A TV satellite. Geosynchronous satellites. What's going on up there? There's debris up there that's knocking down satellites all over the place. How much space do we have left for satellites? What are the periods of the satellites? You really need to know something about satellites if you're going to be a CEO of a company and someone's going to talk you into putting up a satellite. Lasers. 10 years ago, 15 years ago, everybody thought we'd be communicating with microwaves, microwave towers. Do you know that most of our communications goes through fibers? Fiber optics? Why? What's going on there? Are we going to have fiber optics to our home? How did lasers take over our communications? How can you communicate with a laser? Radioactivity. Early in the class, we get into radioactivity. And on the first lecture on radioactivity, we talk about the radiation effects, the biological effects. How much radiation does it take to cause cancer? What are the dangers? If there's a radiation release in Berkeley, and you look at the numbers, you'll know whether to be worried or not. I think everybody should. How many people died of radiation from Hiroshima? I don't mean among you. But these are numbers that get some sense. Nuclear reactors, nuclear bombs. I think I teach the only course in the University of California at Berkeley that shows you how to design a nuclear bomb. Okay? And, you know, not the details, but the general picture. Do you want plutonium or do you want uranium? How much should we worry if a terrorist has stolen some uranium-238 or uranium-235 or plutonium? What kind of bombs do we think North Korea has? Why are we so worried about the things that they're doing up there? What are they doing up there? What is this reprocessing business? What is these centrifuges that we found in Iraq? What's going on there? What is a calutron? Saddam Hussein was building calutrons. This was for his bomb project. You know what calutron is named after? Some of you are wearing it on your shirts. Cal was named after the University of California at Berkeley, the calutron. That's what Saddam Hussein was building. Surprised all of us when we found out about it. This is stuff you really should know if you're going to really have an important position in the world. Medical imaging, what is MRI, X-ray, CAT scans. Interesting stories here. Biophysics, geophysics, astrophysics, I consider them all parts of physics. So I take the most interesting topics from Alex's course and I stick that into the physics course, and I take the most interesting geophysics. You'll learn all about earthquakes. I keep on telling my class, as my students will tell you, that I keep on praying there'll be an earthquake during class so that I can sense the P wave and then I can sense the S wave and estimate the distance to the earthquake from how they came relative to each other. So why do earthquakes destroy some buildings and not others? Why is this? What's going on in an earthquake? How does an earthquake get from the epicenter to us? All that sort of stuff. Important stuff to know if you're going to site your building. Do you want to put it down on the landfill? Do you want to put it up on hard rock? Do you want to put it close to the fault or far from the fault? The answers here are not obvious. Current events. We'll often stop a lecture to talk about, well, I gave a lecture on the fires taking place in Southern California, the physics of fires. There's the physics of hurricanes about a month earlier when they were the big hurricanes. Hurricanes and fires are really interesting things. I cannot cover everything in this course, everything in physics. But I figure if you get a semester in which, with content and lots of material, and a real hard semester of physics, a lot of work, a lot of reading, a lot of learning, it's amazing what the students learn. I'm always proud of the students because they do so well on the exams. With a semester of physics, you're off to a good start. At the end of my course, one of my goals is that you will, from then on, when you pick up the newspaper, read the science section. You will read articles on technology because you'll know it's material you can understand. And you'll get out of those articles the key things you need to know. We live in a technological world. You cannot function well in a technological world unless you really understand the foundations of technology. Let me say again, physics is the liberal arts of technology. Terrorism, counterterrorism, Stinger missiles. What's going on with Stinger missiles? We worry that they're shooting down our helicopters with Stinger missiles. What is it? How does that work? How does it see in the dark? What's going on there? Night vision, airport security. How does that work? How important is it? What's going on? How do they detect weapons? Now, there are a few things I do cover. I mean, I confess, only probably 80 to 85% of the material is material you absolutely need to know to be a future world leader. The other 15%, I slip and we talk about black holes, and we talk about the theory of relativity and the uncertainty principle and these issues of physics, quantum mechanics, how we're all actually waves. This is for a little bit of cultural enlightenment. It's less important than the other stuff, but many people are attracted to physics because of these mysteries, and they are mysteries you can understand. And I'll teach them to you in a way that you'll understand them. And you'll go home and you'll tell your physics major friends what you learned, and they'll say, oh, we haven't gotten to that yet. We have a nice lecture. Another thing you don't really need to know are the illusions of Disneyland. Every student who's taking this course should take a trip to Disneyland, go to the haunted house, look at those illusions, and try to figure out how they work. You don't have to do it during the class or before, but certainly sometime in your life when you're taking the course, we discuss all that stuff. So let me finish up by giving you a few exam questions. This was from my final exam last semester. President Bush announced that we're going to have a hydrogen economy, and he's investing a large amount of money in this. What does that mean? How is hydrogen used in the hydrogen economy? Where does it come from? What are the misimpressions people have about the hydrogen economy that they shouldn't have? That was my, write an essay, write a page on that topic. Virtually everybody in my class was capable of writing a page on that topic. Some did better than others. What I want you to get out of this course is I want you to be articulate on technical subjects that have important consequences. I want you to be able to go home and argue with your dad and mom and straighten them out on things where they have misinformation. Gases are being dumped in the atmosphere, which could have major environmental consequences. We've discussed this in our course. Describe them. That's the question. At that point, if you've taken this course, you're supposed to say carbon dioxide is a greenhouse gas. It increases the greenhouse effect, which is already operating, and could raise the temperature and be responsible for global warming. You're also supposed to say chlorofluorocarbons, CFCs, like Freon. We're destroying the ozone hole. The danger there is that with the ozone destroyed, ultraviolet radiation will come to the Earth, give us cancer and sunburn. And that's really all I wanted. But I wanted you to be able to answer that question without too many hints. I want you to say, we're dumping pollutants into the atmosphere. Tell me about it. Go into some more detail if you haven't. That's what I'm looking for. That's what you will be able to do at the end of this course if you choose to take it. Radiation is leaked in Berkeley. 1,000 people are expected to be exposed to 1,000 millirem. The mayor of Berkeley says, you took physics 10. Tell me, should I be worried? What should I do? And then you write an essay addressed to the mayor of Berkeley describing how many people will die, what the other consequences will be, radiation illness, and so on, and give some simple numbers. It's not much in the way of calculation, but you have to know how many millirem it takes to cause a cancer. You have to know about the linear hypothesis, which tells you what happens when you expose a large number of people, each one to a small dose. Controversial hypothesis. You have to know it's controversial, but nonetheless, it's what the mayor would want you to use. So let me finish up with my great success story. Okay, a student came back to me who had taken the course a year earlier and came to visit me during my office hours. And she just wanted to tell me she had gotten a summer job at Livermore. And she found herself at one point at a table full of physicists. And they were talking about fusion as a future energy source. And they talked about it, they were enthusiastic, and some people said it wouldn't work, and it was interesting. She was listening to all this. And then there was a pause. And she said, I think solar power has a real future too. And the way she described it to me is they gave her sort of a mild chuckle. And one of the physicists said to her, look, if you want to power even California with solar energy, you'd have to plaster the whole state with solar cells. And she said, no, I don't think that's right. You know, every square kilometer has a gigawatt of solar power. And even if you're inefficient, California's only 20 gigawatts total electric. And so it wouldn't take much area at all. She says there was silence around the table. And finally someone said, well, your numbers may be right. We'll have to go check that. That's the triumph of my course. That's what I aspire all of you to be able to do, to shut up a table of physicists who haven't thought, who have accepted an urban legend and haven't thought through a subject because you know the numbers, you know what's important, you have a relative feeling for what's going on. So I want you all in my class next semester, Tuesday, Thursday, 11 to 12:30. And if you can't take it next semester, take it the semester afterwards.
So Rich, before we go down, how many of these things does George Bush know?
I assume he knows all this stuff. He's already president. He must know this stuff. Yes. Well, wait, let's have our questions. Everybody together for questions? Everybody up for questions.